All right. Welcome everybody. Um, Today's day 12. We're in week 3, day 3, technically. Okay, so today's question of the day is what's the coolest tech gadget or software or tool or something dealing with tech that you've recently discovered and maybe you wish you had, or maybe you do have and then you found? I like asking this question, and I'll probably ask this again later on in the course. Because I just think it's cool to hear of the different things that you guys have found out and stuff like that. Because there's always really cool things. And so with that being said, I'll start out. And I think the what came to my mind when I read this question was so there's these like new like AI is like doing so many different things. Like there's so many different AI tools. And one of them that just came out that isn't available to the public yet. I don't remember the name of it. I need to find it. But basically it's like you can prompt the AI to build a world for you. Like for example, a game. And then you're able to kind of look through and kind of play that game from that singular prompt. It's not like coding it for you. It's not like you have the code for it, but it's like you're able to kind of I need to find the video on it. I was reading up on it and watched this video on it. But yeah, you're able to like I think it's from Google, and you're able to just give it a prompt, and it's like it makes this interactive world for you, which I think is super cool. It's really interesting. And kind of building upon that, there's another one. I don't know if it's the same one or this is a different one, but it's like based on an image. It's like you can make it come to life in a sense. Like one guy did like Van Gogh's Starry Night, where like he gave it the picture and was like, make a game, make it interactive kind of thing. And so he was literally able to like walk through, Starry Night or whatever it is, that you're doing. Which I think is just, I think those things are so interesting. And they're not available to the public yet, I don't think. But those are things that they're testing out. I just think it's so cool and I'd love to mess around with it. Um, Junior, the first on my screen, please take it away.
Man, yeah, I mean, I'm fascinated by that AI stuff. It's I don't understand it or whatnot. But maybe to kind of think back a little bit. Um, when I used to play for some of the teams back then, our training was basically, hey, you know what, get out there and just work harder and whatnot. But I remember there was this guy that he was younger than me, and then he went off to play on some, I think it was rugby or something like that. But they were telling me that they would hook up the players to like these monitors and whatnot that would measure the amount of steps that they would take, their heart rate, and all these kind of metrics. And it was just kind of like it was so refined that working hard, you could tell if an athlete was giving their best or not, regardless of the amount of playing time or what they were doing on the field or the court or whatnot. So I thought that was pretty interesting, right? Because back in the day, it's like, hey man, stop shamming or whatever like that, do your best or whatnot. But now, I mean, they got things that will measure your output and how much volume you're doing, and it's just incredible. I think it's an incredible time to like get into athletics and whatnot. But I don't know what that looks like, 5 years from now. I know it pushes the limits and whatnot, and just I guess kind of circle it back to AI. I don't know where everything is going to look like in the future, but technology, right? Yeah. Let's see. Adrian.
It's funny that you mentioned like tools that track your calories or like your steps and whatever, because I actually have one with me right now. So does do people here have a Garmin? Or do you guys have like a Garmin or like a watch? No? Okay, cool. But like, oh, you do? Okay, cool. Um, it's really cool, and I was very ignorant of it. Like, I'm like, wow, this can track my sleep, and this can also track what else can it track? Track my steps. Track the miles I do, like let's say I go running and it has a GPS location of where I'm at, and then it will calculate where I'm gonna be at throughout the route I took, the average pace I've been going. Like that's really cool. Like especially as a runner, having that data is really useful. And I know like Run Guam like sells that, and it's very helpful. Like you said, Junior, like this is like next level stuff that we probably we didn't have like what 10 years ago, which is really cool. Uh, besides that, like the other thing I wanted to mention too is like when I went to Japan for the first time ever, I know it's not a new topic to talk about, but like I love the idea of IC cards when you go on a train. You go on a train, you just like tap the IC card, you just go into the train and then they just charge you right after. There's no like and the flow is so seamless. I'm like, man, I wish we had that on Guam, but that's like next to impossible. Because like we had to like take decades to make the train system here. But I don't know. Those two things, like having that the Garmin, for instance, and the IC card, those are really cool tech to me. Um, let's go with Ron.
I guess to just add on to that, the AI topic we're on, I was heading to work this morning, right? And then I was listening to the radio station, and then the host said something about so like how everyone's like kind of freaking out about AI, like they're not sure where it's going, if it's a good thing. I mean, obviously it's done some good stuff, but then he said that I guess one of his uncles or something, like back in the 80s, that's how they felt about like when Google was coming out. So like maybe that's how we're feeling about AI right now and stuff like that. But a tech that I think I recently came across, it's been out for some time. I don't know if you guys are familiar with Starlink by Elon Musk. Yeah. So I think it's pretty cool, like how you can be somewhere super remote and just set it up and then put it to the Roam. What is it? The Roam feature, and you could have initially internet anywhere. And I'll pass it on to
Sorry, can I comment on
Kiko.
that?
Yeah, go
Um,
for it.
sorry, just to make it quick. There's vlogs of people traveling around and are using Starlink as a way to like do YouTube content and just do like trailing and stuff. I don't know. That was cool to me. Yeah.
So, uh, going back to how AI helps, there's this group of filmmakers that I absolutely like, not obsess over, but like they're idols in my eyes because they took Hollywood cinematics and they changed the game with stabilizers and handhelds and drones and putting giant cameras on them and then progressively making them smaller, thinner, lighter and more memory, more processing, more the whole tech works. Uh, what's been catching the attention though for me are like handheld 3D mappers. So they look like kind of something like this. This is a gimbal, like a stabilizer. But on the top, they have a system where it's like a security camera looking bulb, and it's a 360 camera. And they just walk around properties like foot by foot, meter by meter, whatever your metrics are. And they pretty much do it 20, 30 times in an hour or in a set amount of time. And it's taking tiny pictures like by the millisecond or whatever you set it to. And it stitches. I've done this with drones. Like I've taken like, say for example, an acre would be like 2,000 photos layered on top of each other and stitch through programs like 40 pixel, uh, a lot of ArcGIS stuff. I don't know if you guys know what that is, but it's just like, like say you have a lamp in front of you, you could take your phone nowadays and just take a photo of it, and it'll metrically put it into dimensions and blueprint it like how we're learning how to do it with code. But the 3D mapping stuff, it's tripping me out because it took them like what surveyors do when we see them on the side of the road. That's what they're doing. They're just doing measurements and then pinging all the information back and forth to build a 3D model. Now they're just using these with the little camera on top and they're just walking around and making entire, I want to say estates to like, has anyone seen an Amazon building, a fulfillment center? They're like the size of a runway pretty much. And they like imagine having to survey that piece of property. It's giant, right? And they're doing it within I can do 30 acres in like 3 hours with the drone. Imagine what you can do with these things. So that's the tech that got me into coding pretty much because I want to be able to not only like build my own systems and softwares and programs, but like progress the tech and myself with coding and programming. So it intertwines all together with everything everyone kind of just said. So it's cool.
Super. And Lana, sorry, I want to comment on everything everyone said, but
So, my sister has this thing. I think it's called a rocket book. I tried to look it up, but it's really cool. It's just like it's like a pad. You have like just a regular pad, and then you can like it comes with like a little pencil, and you write on it like your notes, and then you just like scan it using an app on your phone, and then it transfers your notes into your phone. And then so you have all your notes on your phone, and then when you're done like writing all your notes, you just like clean it off with like a wet cloth. You clean it off, and then you like restart, and you can just like have so many notes downloaded to your phone without using like a lot of paper, or like having to like go through all the pages in your notebook, it's really cool. Yeah, that's what came to mind.
super cool. Thank you all for sharing. This is why I like asking this question. And to be honest, I'll probably ask it again later on in the class, just because I feel like there's always some super cool, interesting things that people find and out there. And maybe I haven't heard it. Like I haven't heard of a lot of the things you guys talked about, which is actually it's super cool. And I'm gonna look into a lot of it. And man, I wanted to respond to like almost everyone. Like, so Ron, I have a Starlink actually. I've been using it for like a year and a half, maybe something like that now. And actually, I love it because even during the storm when it's really bad, like it maybe gets a little slow if it's like really stormy, but for the most part, like as long as I have power, I have internet. And so it's been super, super helpful. And I set it up for my parents and for a couple of my uncles, for actually my girlfriend's family too, did it there, et cetera. And so it's actually been really cool. And then Kiko, I used to actually work at an Amazon fulfillment center. So yeah, those things are massive. In Vegas, before I was a software engineer, I worked at an Amazon fulfillment center. And yeah, and then there's a lot of cool tools that I guess kind of to junior to your thing, like and Adrian, one of my friends, he connects his Garmin watch to it's a band that goes around your chest and then to track his heartbeat and all that stuff. And it's so helpful to like when we're running, he's so good at keeping his pace and knowing what pace to run at to keep him kind of within that range that he wants to go to and all those things. And so it's actually, sorry, I have a lot. There's something to say for like kind of what everyone. So really cool. Thank you all for sharing. Really, I'm really, really interested in all these things. That's why it's like, I'm gonna ask this question again. Okay. So before I let you guys start demoing you guys' homework, let's go through quick hotkey. It's kind of like actually it's kind of a hotkey, it's kind of not. It's more like a tool you can use, more or less. And so, oh shoot. So in Ruby provides this. I looked it up, what's a technical term? So it's IRB, but it stands for Interactive Ruby. And basically it allows you to kind of have a playground to run Ruby code. So like it doesn't matter where I'm at. For example, I'm gonna go to a terminal. Let me go to a different terminal, for example, just to show you guys. So as we can see here, I'm in the root directory of my computer. So I did the CD tilde and I'm in the root directory. If I type in IRB, it opens up interactive Ruby, and here's where I can pretty much run any code. Like I can write some code and just run it, and it just runs. And what I mean by that, so like let's say I did test equals something, and then I did like test dot upcase. Cool, I can see that, allows me to see what does test.upcase do. Or if I wanted to test, like this is a way that like, let's say you found a method that you want to try out, you can kind of just do it here, test.reverse. If I wanted to write a method, I could write a method def greet. And then it knows, so we can see that it has a star here. So it knows that because I started this line, I haven't finished it yet. So I'm still technically within the method. So I do def greet puts hello or half a day. Half a day. And then I'm going to put my end, and we can see now it kind of indented it the other way. And so we can see this is where the ending of my method is. And so now I can call greet, and it says half a day, or it does whatever it is. It's returning nil, which is actually really cool that it shares that. But we can see that there it says half a day, or I can just so I can write some code here and I can run it really quick without having to open up VS Code or anything like that. I can just run it in here, which is actually really cool. So this is called Interactive Ruby. I did test on my Windows laptop, so I know this works beforehand. But yeah, so you literally just type in IRB and then you're kind of in here. And then to exit it, you just type in exit and now I'm outside of it. So it's really cool. However, one thing to note though is the stuff that you do within here, it's only going to be like available during that session. So for example, if I restart IRB and I type in test, it gives me an error. Wrong number of arguments. It doesn't know what test is basically. I was expecting to get a different error. But test was originally something. It was a string. But obviously the second time, because I stopped it and restarted it, now it's no test is no longer something. Test is nothing. And so that's one thing to know with this. It's like per session, that's like if you restart your session, it's going to restart the stuff that you had. Okay, so that's IRB. And actually, the other tool that I was messing with while you guys were sitting here for a few minutes when class started, because I was messing with this. So there's this thing called binding.irb. I was doing some research about IRB because I wanted to show you guys other stuff about it. But if you use binding.irb, it basically it helps you to debug things. And this is going to make maybe more sense in the future. But actually, it should make sense right now. So let's say, so right now, when we're running our code, if we're going to debug something, I'm going to do like puts. I'm going to do like, if I wanted to know what's name here, I'll do like puts at name. And so now when I run this code, if I go ruby op.rb, and actually, I'm going to go like this, puts, and to make it super clear, I'm going to add some lines. Okay, so there you go. If I run this code again, we can see name first is Leon, and then it's Alana, kind of like what we expect. However, even a cooler thing to do is we can use this thing called binding.irb. And so this basically, it stops as soon as the code gets to right here, it's going to stop the code. And like it's still going to be running, and we're going to kind of like it's weird because it's like we're able to like step into the code right there and like mess around with the code at this specific state. And what I mean by that is if I run the code now that I uncommented binding.irb, I'm going to click enter. And so we can see it's running right here and it's saying, hey, I stopped right here. So like, and it's giving me like an interactive Ruby session where, but this IRB is it has the context to what's in this file. So now like if I did at name, we can see at name is Leon, which is really cool. If I did at age, we can see it's 26. And I can mess around. Like, let's say I was debugging to try to figure out what's going on here. If I put binding.irb, I'm able to mess around with the code in this specific, like during the process while it's running, which is actually really cool. This is going to come a lot more in handy as we get to more complex things. Right now, obviously, this is a really simple method, but in the future, like if one method, like if you guys remember like that method that I showed you guys that was like 600 lines long, that's where these things are going to come in like become super helpful. But yeah, so this is IRB and then binding.irb. Okay. Okay, let me go ahead. Okay. Let me know if you guys have questions about that. Cool. So now, do we have any volunteers for the order we're gonna go in?
I can
Volunteer.
go
All
first.
right, solid. Cool. You are good to share your screen and go and start it up.
Okay, one sec.
Yeah.
Can you guys see my screen?
Yes.
Okay, cool. So basically, I just started off the blueprint or the class as this Steam library. I kind of just based it off like if you ever have Steam as an application, it's basically where you get games for your PC or one of the apps. But anyway, so I put in the attribute accessor to get the title, the genre, and like if it's a single player game or multiplayer game. So I put the definition here to initialize to get the title, genre, and players. And then the next one I got for the custom method is you define the info. So we're getting the title, genre, and players over here. So it's gonna return title is a let's say fighting game for two players. And we added another custom method where it shows that if it's a multiplayer game or not, it will label it if it is a multiplayer game. So you can see two examples of this. So I put game one to be like, let's say Cyberpunk. The genre is going to be action RPG and it's a single player game. And I put Tekken over here as a two-player game and a fighting game. So if we run this right now, sorry, 1 second. Oh, I didn't do this. Sorry, I have to replace game with Steam library. So it shows here, Cyberpunk 2077 is an action RPG for one player. So multiplayer game is says it's false. Tekken is a fighting game for two players. It shows true for a multiplayer game. So that's kind of the basic rundown for the code I did for the homework.
Super cool. I like it a lot actually. And I like it how you, made it towards what, you enjoy, games and stuff like that. No, it's really
Yeah.
all right. Thank you for sharing. Do we have any Thank you very much, Adrian. Great work. Do you have any other volunteers before I start selecting and just selecting random?
Sure, I'll go then.
All right. Thank you, Junior.
All right. All right, here we go. Do this. All right. Is it showing?
Yes.
All right. So class is a player. I call it a player. We initialize it with three, name, sport, division. So the name at name, instance variable, sport, instant variable division. We end that. We do the attribute reader one, attribute writer one. The definition, I made profile, and it just returns the player name, the sport, and division. So initialize player one is equal to play, we call the class dot new, and we feed in the three. What would I call it again? The arguments? Are they arguments or?
Yes. So technically on 18, there you're passing in arguments, and then up above in the actual initialize, it's technically parameters up there. Like you're using the parameters down here, it's like you're passing in arguments. That's the technical thing. Yeah.
Okay. So there's that. And so I called each one of them, and then you can even do the profile. So I ran it down here, but if we run it again, um, we see there's my name, the sport, division, and then with the profile.
Super cool. Nice. Great work. Do you play with Coach D and Coach Steve and those guys?
Yeah, so I'm in the 90s group. So Coach Steve, when I started playing, they went to I would meet them in Gany Heights gym. And then so I really got into volleyball in the 90s and then started playing. Eventually was able to make the national team, played a good number of years and
Yeah.
even coached a little bit there. But yeah, Coach Steve, man, he kept volleyball alive for a very long time. So our club is kind of restarting our youth program and whatnot. But yeah, Steve and D, man, shoot, we go 30 plus years, man.
Yeah.
Yeah.
No, they were my coaches since sixth grade. I used to play volleyball a bunch, that's why. So six,
Yeah.
push-up, and then FD, and then stuff like that. Really cool. Well, tell them I said hi next time you see them.
Solid, yeah.
Sorry, Junior. This I try to find an opportunity to ask you this too, but like, so I actually played for Ugudu's team. I
Oh,
was JV, well, but I was like class 2018, or I was JV. Um, yeah, I was just a libero. I was just trying to play again, just so I can get back into playing. So I
yeah.
was wondering, like, the Ganya gym is open, like
So Gany
is it
Heights,
like an open gym?
I think at Gany Heights they still do Tuesday, Thursday. You play for Okudu, right? So was that Dom and Alvarez and um, I don't know, but Ruel Estoy was who,
Yeah, yeah,
who
yeah. That was my coach.
yeah. So those guys, I guess they kind of been playing for his name is Algoritho. So I played under Al for some time, but they play under Legacy now. Um,
Oh, cool.
but
Yeah. So
yeah,
sorry,
like
the the superstars of our team was like Gary Roman and I forgot Ryan. I forgot their name, but yeah,
yeah.
they were hard hitters.
Yeah, Okudu, man. I remember they always put in a competitive team. So cool.
Super cool. Thank you. Um, Volunteers for next, Kiko, Ron.
I'll go next.
Solid.
Let me check my screen real quick. Can everyone see it?
It's loading for me.
Oh, okay.
It's still loading for me. I don't see it yet. It's like a black screen. It says you started sharing, but I just don't see it. Okay, there, I see it now.
Okay, so it's just a bunch of gibberish. Surfboards are measured with length. Sorry, hold on. Or if you can see here, it's like a length, width, and height, or thickness, width, and height, right? So I used attribute accessor so I didn't have to keep going back and forth. Um I initialized it. Or how do you say this? You gave it I like to say value or give it
Yeah.
its yeah.
You passing
And
the
then
arguments.
yeah, and then I went in and I asked for its info, which is
Where
just random stuff like length, who shaped it, then the dimensions on the end. And then uh I gave it its own little like I didn't want to say like surfboard one all the time, so I just made it like I grouped it into its own little like a posse, and then I made it, or what are those variables or whatever, or the what you made us do where we changed it up a little bit, where I just made it tell you if it passed inspection or not, and then
Mhm.
they got yeah, and then if it didn't, you give it a reason why. I forgot how to like make it like seek the command, but I just separated everything and then I made it print out all the board info so you could have it on the bottom. So if I hit it here, or sorry, it all works. So here on the bottom, let me pull this up real quick. So you can see it printed out. This board from Ocean Beach or Ocean Beach Surf Club is 6 foot. Merrick shaped it. It's 19, and uh, I made it do fractions, but it was a lot harder to read. So I made it go back and do decimals, and it was so much better. Um, and then I kind of wanted it to be stacked in a different format, so I tried different ones. If you guys can see this, and yeah, this was like the the I could have done this with the getter and setter, but I wanted it to look a lot cleaner and just a lot simpler. So I did it in the prints, surfboard one length, shaper dimensions, if it passed inspection, and then that it printed out like this on the bottom. I could have had it like this, but I just wanted it a lot more, or they're both readable in the sense that they're all the info's there that we put in, but you have a listed this way and then you have a listed that way, either way.
Super solid. I like it. And I really like how you're using like you're making it very readable by using all those lines and being really explicit with all that. So I think that's really cool and I like it a lot. So super cool. Great work, Kiko.
Thank you.
Yeah. And then Ron.
sorry, I'm gonna be honest, I'm not done with mine yet, so maybe I'll just push it up later if that's okay.
No worries. Are you okay with sharing what you have so far? Just it doesn't have to be working, just share like what it is that like what you're envisioning or what you're working towards, maybe. Is that cool with you?
Yeah, I was doing like well, I used balls, so I'm thinking more like uh the dimensions for like a basketball or something. But I didn't really get far. Yeah. So, but I'll work on it.
I got you. No worries. Really cool. Well, thank you all for sharing. You guys are all killing it. And one thing I want to share with you guys real quick, before we continue with the lessons is we're gonna more often do these time. I really like doing these things where you guys are kind of explaining what you did in a technical way and non-technical way. And my reasoning behind that is because I found that like in interviews or in things like that, like you're gonna have to explain your stuff to somebody. Like maybe you're working on a team. You're gonna have to explain what you're doing. And so the more confident and the easier, the more you do it and the more confident you feel with kind of being able to talk in a technical and non-technical way to explain what you did and why, the better it is going to be for you guys. And so we're going to be doing this relatively often because I just want you guys to practice talking about what you did and why you did it. And I guess kind of last thing I'll say on this is in the interview where I landed my first software engineering job, literally the interview was the engineering manager wanted me to talk through what I built for my capstone and why I chose to build it and different things about that. And so with that being said, that's why I want you guys to practice that as much as you possibly can. Like whenever, or like not as much, but like, throughout the class. I'm gonna have you guys doing that because that's literally what landed me my first job, being able to communicate what it is I'm doing, why I'm doing it, maybe some issues that I worked through, some things I liked or whatever it may be. And so that's where I want you guys to practice that too. Cool. Okay. Let's see. Let me go ahead and share my screen. Oop, dang. There we go. Okay. So I'm just gonna delete all this. All right. Let's see. We are going to continue with object-oriented programming. And actually, before I'm going to give you guys another homework potentially tonight and to show you guys kind of an idea of what it's going to look like or like where we're going with this OOP stuff, like one place that or like kind of the direction we're looking at with this. And here, I'm going to show you guys this. I'm going to comment this out. I'm going to do this. I have this solution. We're not going to go through this right now, but let's go and do this. Getting that error. My ends, loop do, else end, when for. It's gonna fail with an error. Why is it giving that error? One, two. Okay, I'm just gonna change this to. I guess I'll fix this and I'll show you guys in a second. Yeah, Lana.
How to do your end right before the when
Right
on
before
line 116.
116. Oh, what is that? What is that character? That's not even in my notes.
What's
Really?
in a queue? Oh my
Yeah,
God, I'm so blind.
cat. I didn't even see that. Yeah, I don't know. It's like I don't even know what character that is. All right, solid. Okay, cool. Thank you, Lana. Okay, so as we've done a few times already, we built these kind of like command line interfaces where we're like, have this loop do, we're giving the user some options, we're allowing them to create something, etc. And so here we have a book manager, and it's going to be the same exact idea. I can add a book. I'm going to click one, title the book, Harry Potter. I don't know. Author of the book, what's her name? Dang, I forgot. I'm drawing a blank. I don't remember. I'm just going to say someone. All right, cool. Book added. I can list all my
Dude,
books.
J.K. Rowling is the most popular
Oh my God. Now I remember.
writer other than Jesus himself in the Bible, bro.
I'm sorry. I'm sorry. I literally just
I'm
drew.
joking, I'm joking. Sorry.
All good, all good. Thank you. Okay, so but anyway, I can see all my books. Let's go ahead and add one more book. Just because you said that, now I'm adding the Bible. And I'm gonna say it was by Jesus. I know there was a bunch of authors, but I'm gonna say it's by Jesus. And then once again, let's just go and view all my pages again. I mean all my books. Cool. I see all my books. And then from there, let's go and click that I read all my pages. I want to do read pages for Harry Potter. I read 100. Cool. And then let's go ahead and view all my books again. Cool. We can see that for Harry Potter, I read 100 pages. And so we can see here, this is the same exact thing really that we've been doing. It's just instead of right here, instead of us pushing in a hash, we're creating an object. And then we're pushing that object that we created into that books array. So this books array is technically just a bunch of objects, which is actually really cool. And so this is the exact same thing. Like there's nothing special about this code. The only difference is instead of us pushing in objects or like I'm sorry, instead of us pushing in hashes, we're creating a book object, an instance of this book class, and we're putting that within the books array, which is actually really cool. And so this is kind of another thing that we can do to build upon exactly what we've been doing already to kind of make it a little bit more complex, or like make it more like the real world in a sense, which I think is really cool. So we'll go through this more in detail later, but I did just want to share this with you guys. And actually, that will be maybe the homework for the weekend. Maybe we'll do that when we can make something like this the homework for the weekend. But really, for any of the ones that you guys have built already, you guys can do something like this where you're just going to create a class for whatever it is you want. And then from there, instead of creating a hash, you're going to be pushing in the object it is that you created, etc., which I think is really cool. Cool. Questions, comments about this before we move on to the next topic? All right, solid. Okay, let me know if you guys do. We'll share that. We'll go through that more later. All right, cool. So I'm going to create a new file because we are going to continue with the next lesson with regards to OOP. All right, so I don't know. I'm gonna call it OOP continue. I'm not sure. Okay, so the next topic within OOP, actually, I guess maybe before we move on, does everyone feel comfortable with OOP? Do we want a quick refresher or anything like that? Everyone seems like they feel pretty good. Just want to make sure before we move on. Okay, just make sure. If you guys have questions, let me know. Okay, so the next concept within object-oriented programming that we are going to go over is something called inheritance. So inheritance. So inheritance is basically it's a kind of fundamental concept within object-oriented programming, but it basically allows a class to inherit attributes and methods from another class. And so this kind of it promotes code reuse and kind of establish kind of like a hierarchy between and hierarchical relationship between classes. And so you can kind of think of inheritance like a family tree. So it's like, let's say you inherit characteristics from your parents. And so similarly in programming, we're going to have a subclass inherit features from the superclass or the class above it, basically. And so, for example, let's say we have a general class animal. And then from there, we have specific animal classes, dog and cat, which inherit from animal. So all of the functionality that animal has, also dog and cat also have. That's that, yeah. So let's go through an example real quick. So we're gonna go, for example, class, and I'm gonna create a class for vehicle. I'm gonna make sure I put my end because wherever there's a start, there's an end. Same thing. And so from there, I'm gonna do my def initialize. Initialize. This is gonna take in a make and a model. Put my end. It's at make equals make. At model equals model. And then from there, I'm just going to create one other method. I'm going to call it info, def info. And this method, all it's going to do is it's going to return vehicle make equals at make. And then what's called vehicle model, or let's go model is model at model. Let's go ahead and just test this out. Before we continue, I don't want to do anything too complex, and I'm like, I don't even know what works and what doesn't work. So I'm going to stop before I create anything else. I'm going to stop and I'm going to try creating a vehicle, make sure I can initialize it with a make and model, and make sure I can get their info. Okay, so let's go ahead and do car equals vehicle dot new, a make and model. I'm going to say Toyota, and then it's going to say Tundra. I don't know. Cool. And so now if I do pcar.info, I should see vehicle make Toyota. Okay, sorry about that. And then model Tundra. So let's go ahead and run this. Oh, wrong file. Ruby OP continue. Perfect. Vehicle make Toyota, model Tundra. Exactly like what we're expecting. Cool. All right, so now let's go ahead and continue. And now I'm going to create a subclass. Okay, cool. So now to create another class, I'm going to do the very similar thing. I'm going to create a class for car because a car is going to be a type of vehicle. And then we'll also do another class, which is going to be motorcycle. So I'm going to create class car. And so this class car is going to inherit from vehicle. So I'm going to do a less than sign vehicle because technically a car inherits from a vehicle. It is a vehicle basically. And I'm going to make sure I do my end. And then from here, everything else in here can look kind of exactly the same. But instead of having to do the initialize, I'm only going to do a number of wheels method to keep it simple. And then here, this is just going to return 4. So now I'm going to do the same exact thing. I'm going to go class and I'm going to go motorcycle, cycle. There you go. And this also inherits from vehicle. I'm going to go end and I'm going to create that same method, number of wheels, and this returns 2. Okay, so the way this works is we have this overall parent, we can call it like the parent class or the super class is what some people might call it, of vehicle. This vehicle class has an initialize method and has an info method. We all understand that. From there, I have 2 subclasses or 2 child classes. And so the first one we have is car. Car inherits from vehicle, which means that all of this functionality in here is also in here. And that's the same thing for motorcycle. All of the functionality in here is also in here because motorcycle and car inherit from vehicle. And the inheritance goes one way. Vehicle does not have access to number of wheels because it's the parent. The parent cannot get the stuff from the child. The child can only get the stuff from the parent. So with that being said, let's go ahead and try this out. So for example, I'm going to do car equals car.new, and then I'm going to pass in Jeep Wrangler. And then now I can do pcar.info, for example. Let's go ahead and start, or actually, let's do the method that's actually there. Car.number of wheels. Let's go ahead and run this and let's make sure it works. Perfect. We see car.number of wheels gives us 4 because it's a car. So it creates this, it initializes a car, and then from there, it's using number of wheels from the car class, which returns 4, exactly like what we expect. And so if I do the same thing, but I do it with motorcycle, I'm going to go motorcycle equals motorcycle.new, passing in Harley, let's say, let's go roadster. And if I do p motorcycle dot number of wheels and run this, I should see 2. Perfect. There's the 2. The reason why it says 2 is because this is of the motorcycle class, and the number of wheels method in the motorcycle class returns 2. So that's why we got 2. And so there's a couple other things going on here that I want to share with you guys. So technically, if you guys remember, the .new method calls initialize. These 2 subclasses do not have an initialize method. So technically, when we're doing this .new, it's going up here and it's doing this. It's doing this initialize method because there's no initialize method in here. And so with that being said, that means also we have this info method. So now I should be able to go pcar.info. And also I should be able to do pmotorcycle.info. And I should be able to run this. If I run this, perfect. We can see vehicle make Jeep model Wrangler, vehicle make Harley model Roadster. Exactly like what we're expecting. Perfect. And so this is the way inheritance works, is we have a kind of parent class, and then we have some child classes or some children classes, some subclasses, I guess, however you want to say it. And so these classes, once again, they inherit from here, which means that all the functionality that this class has, the parent class has, the child or the subclasses also have. Does this idea make sense to everybody? Cool. Super cool. Okay. Any questions before I give you guys an exercise to try it out? Solid. Okay. Let me know if you guys do, but I'm going to give you guys an exercise. I'm going to give you guys an exercise and we'll take a break right after. All right, so you guys exercise. I want you to create a person superclass or parent class and student and teacher subclasses or child classes. And so your instructions define a person class with attributes for name and age and a method introduce. Then from there, you're going to create student and teacher subclasses that inherit from person. You're going to add a grade attribute to student and a subject attribute to teacher. And then from there, you're going to instantiate or create objects from both subclasses and call their methods. Okay. Yeah, just I'd say my recommendation here, take this step by step, do the first step, test it out. Then do the next step, test it out, and do the next one, etc. I'm not expecting anyone here to just do all four A, B, C, D here and then test it. I want you guys to do it one by one. The other thing I quickly want to share with you guys before I let you guys go is if you guys notice, I do not have add a reader, add a writer. I don't have any getter or setters. If you don't need it, then you don't then you're not going to write it out. You're not going to code. You're not going to add that to the code. You're only going to add what makes sense to have. Right now, I have no reason to do getter and setter methods because we set them up with the initialize. And then from there, technically my getter method is kind of like this info. That's all I want. I don't care to have the user have access to see what the make and model is by itself. If you want the make and model, you can do the .info method. So that's why I don't need a getter and setter. I don't need the add a reader, add a writer, add a accessor. And so that's the other thing I want to note is you guys don't need that. If you did want to give the user access to it, by all means, go ahead and write it out. But for me specifically, to keep it simple, it's like, why write it if I don't need it? Cool. And here, I'm gonna go ahead and I will share you guys this code for you guys' example. Example, inheritance. All right, cool. So on that note, you guys are good to share your screen and try that out. All right. So does anybody want to share their solution? we're gonna work through it together because there's a few things that there's actually one thing I didn't share with you guys yet explicitly, but yeah. Anyone want to share their solution? Not mandatory this time.
I can do it.
Solid. Thank you, Adrian. You're good to share your screen and see it. All right, the floor is yours. I'm meeting up. Hey, Adrian, you're muted.
Hello. Okay, cool. Uh, can you guys hear me? Okay, cool. So we're putting a new class, which is person, and we're setting the attributes to be name and age. So we're basically gonna define um an initialized name and age, and we're putting an introduce function or introduce, uh, saying my name is whatever and I am blank years old, and then we'll be starting to do the subclasses right after. So the subclasses are going to be student and teacher. So um so the attribute that's going to be added onto this will be grade for student for the subclass. So we're going to initialize everything from the parent, and then we're going to add on um the grade for the subclass. And same thing here for a subclass with the teacher, but the attribute is going to be subject. So we initialize, and basically, from my understanding, the super is like get everything from the parent, and then we'll just add our attribute last. And then so we put an additional introduce for this one. Um, my name is whatever. I am blank years old, and I teach this subject. Sorry for this one too. It's going to be grade. They're going to say their grade. So we defined student. I put my name, age, grade. For teacher, I just did name, age, and the subject. And we'll test out the code here. Actually, it's already here. So I started off the code and it printed out my name is Adrian, I am 26 years old. My name is Carrie, and I am 50 years old. I teach PE. Yeah.
Think I was muted. Sorry about that. But solid. Great work. Yeah, actually, super is the next thing that we're gonna go through after we kind of walk through the solution. So really cool. All right, you're good to stop sharing your screen, and I'm gonna share, and I'm gonna walk through something right before we go through. I'm gonna show you guys like what it looks like before it. So let's go ahead and do this. I'm gonna grab this. Yeah, and I added this hint after that. Sorry, I even forgot to say it. You might need to create individual initialized methods for each class. I added that after. Sorry about that, guys. Forgot to say that. Okay. So let's go and do this. All right. So create a person superclass and student and teacher subclasses. So define a person class with attributes for name and age and a method introduce. So right off the back, I'm going to go class person end. I'm going to make sure I put my end right away. And then I'm going to go one tab in and I'm going to do the initialize method. Initialize. That's going to take in a name and an age. I'm going to go down and make sure I do my end right away. And then from there, it's at name equals name, at age equals age. Perfect. And then they want an introduce method. So introduce, put my end, and I can I'm gonna go return, and then half a day. My name is at name, and I'm at age years old. Perfect. And so before I even create my student and teacher subclasses, I'm going to test this out. Let's go like person equals person.new, passing in a name and an age. So let's go like Let's go Lana 23. P person dot introduce. And so this should print out Hafide. My name is Lana and I'm 23 years old. If I run this, perfect. Hafide, my name is Lana and I'm 23 years old. Exactly like what we expect. So this is what we're used to already. Cool. So the next thing I can do is now that I have that set up, now I can create my subclasses. And my subclasses are always going to be outside. So the classes that you create are always going to be outside. Like I'm never going to create a class within another class. It's always going to be outside. So the next class I'm going to do, the next one it said was a student and teacher. So let's go and start with student. Student, and this inherits from person. Do my end. And so this one says that, so we're going to add a grade attribute to student and a subject attribute to teacher. And so, yeah, so we're going to add a grade attribute. Okay, so with that being said, I'm going to go def initialize. And so because it wants us to create a specific attribute for student, so it says add grade attribute to student. So this attribute, these are the attributes, name and age, for example, for person. And for student, it wants name, age, and grade. So I'm going to go def initialize. I'm going to go name, age, and grade. And then I'm going to go my end. And then for here, we're just going to do the same thing. At name equals name, at age equals age, at grade equals grade. And so one thing I want you guys to see here is that even though, so if we have two methods that are that are named the same thing in like a subclass and a superclass, we're going to use whichever one is a part of the one that we're a part of the class that we're calling. So right now, if I was to do student equals student.new, passing in, let's say the next person on my screen is junior, age 26 and grade 12, say. So this like this dot new, which we know calls initialize, is calling here. It's not calling here. It's calling here because we have an initialize method. If we didn't have an initialize method here, if I comment that out, now this dot new is going to go here first because it's a student. It's going to go to the student class. Is there initialize method here? No, there isn't. Let's go to the class that inherits from person. Okay, cool. There's an initialize method here. Let's do this one. So that's the way it's working. It's starting here in the class that you're referencing, for example, student. If there's nothing there, then that's where then it goes to the class it inherits from, not vice versa. So that's why I'm recreating this initialize method in the student class. And so now I can do, for example, p student dot introduce. And so now let's go ahead and run this. Cool. Hafide, my name is Junior and I'm 26 years old. However, we can see here that there's kind of something missing. It's like we're not doing anything with the grade. So here's where, actually, there's kind of two things that we can do. For one, we can see this is repetitive. This is repetitive because it's like we have that up here. So that's where kind of the next concept that Adrian was bringing up of super comes in. And so you're right on the money, Adrian. Super is basically a way that says like, hey, if there's the exact same thing above, use the exact same thing above and like add it on to whatever it is we're doing. So for example, we could go def, and I'm going to create introduce. I'm going to name it the exact same thing on purpose. And I'm going to put my end. And then from here, I'm going to go super plus, and then I'm going to go, so we're doing some concatenation here. So we're going to go super plus, and then whatever it is we want to say. And we're going to go, and I'm grade at grade. So now the way this is going to work is when I call introduce as a student, it's first going to come here to this student class. Where's the method introduce? Okay, cool. It's right here. So it says super. Okay, so there must be a parent class that also has this exact same introduce method. So let's go there. All right, cool. Here's the parent class. It inherits from person. Here it is. Do this, basically, and add that to this. So grab the original one and add it to whatever it is I'm telling you to add here. So now if I run this, perfect. Hafide, my name is Junior. I'm 26 years old and I'm grade 12. And to make it a little bit better, let me go ahead and add that space. Perfect. And I'm grade 12 right there. That's the way super works. Is it's like, okay, cool. If we have the exact same thing above, let's go ahead and reuse that functionality. The technical, like the notes that I have on super is it says the super keyword allows a subclass to call a method of the same name to its or from its superclass. And so basically this is the subclass or the child, and we're able to call a method with the exact same name. That's why I named it introduce from the parent class or the super class. So that's the way it works. It's useful. It's useful when you want to build upon the functionality of a superclass method rather than completely replacing it. So right now it's like it doesn't make sense for us to rewrite this whole introduce method specifically for a student. So it's like let's reuse what we have here and just add on what's specific to a student. Does that make sense with everybody? Cool. Okay. And so with this being said, we can do this exact same thing, but for a teacher now. So a teacher, it says here, we want a subject attribute for a teacher. So let's go ahead and do that. So I'm going to go, let me comment this out so it doesn't run when I run it. And we're going to go class teacher inherits from person. I'm going to create my end. I'm going to go inside and I'm going to go def initialize. So we have name, age, and this time we have subject. End at name equals name, at subject or at age equals age, and at subject equals subject. And then from there, we're going to do the same thing. We're literally just going to, I'm just going to copy this whole thing and paste it right there. And instead of it being grade, it's going to be subject. Perfect. And so now if I create a teacher, teacher equals teacher.new. And now we're going to pass in a name, an age, and a subject. So the name, for example, the next person on my screen is Ron. We're going to go Ron, 26, and the subject you teach is computer science. And if I go p teacher.introduce, so now the way this should work is we create a new teacher, we initialize it, so it's going to go here to the initialize method because it's .new with the name with the arguments that we're passing in, and then from there, then we're going to call teacher.introduce. Teacher.introduce is going to come here, introduce super. Okay, let's go to the person. Let's go to the parent class up here. All right, cool. So let's grab all of this stuff that the parent class's introduce method does. Let's bring it down here and let's add that to what we have here in our introduce method. And maybe this one, and I teach subject, whatever that is. Okay, so now if I run this, click enter. Hoffaday, my name is Ron. I'm 26 years old and I teach computer science. Perfect, exactly like what we're expecting. And so we can see here, and I'm going to move all this, I'll move it all down. Let's do that one, and then grab this one too. So we have three different classes here. We have a person, we have a student, and we have a teacher. Student and teacher both, what's it called, inherit from person. But we have technically, these are kind of like almost all identically the same, except for person, we only pass in two arguments because the person class only has name and age. For the student and teacher, we're passing in three because both of them have three. They expect three arguments or three attributes basically. And so we also have introduced for all of them. And so now if I run it with all three, perfect. Hoffaday, my name is Lana, I'm 23. Hoffaday, my name is Junior, I'm 26, and I'm grade 12. Hoffaday, I'm Ron, I'm 26, and I teach computer science. Exactly like what we expect. Questions? Okay. The last thing that I'll share, which is actually the other thing that we can do with super that Adrian mentioned, is instead of, this is pretty redundant too. It's like we have to write at name, at age, all that stuff every single time. No, we do not. We have to write whichever one is specific to this class. And then from there, we can just go super, passing in name and age. So this basically does this for us. So that way we don't have to write it. And just to show you guys that it still works, perfect. We're not getting any errors. And so I'm going to do the same thing here. Super, passing in name and age. Run it, perfect, still works. And so this syntax right here, we still have to pass in all three attributes because it's expecting it. As soon as I delete this, if I just wanted age or grade, for example, now if I run this code, this is gonna break. It's breaking on line 57 right here. And technically it's coming from line 81 right here because we're attempting to create a student. It says wrong number of arguments, given 3, expected 1. We passed in 3 arguments right here when we created a student, but when we initialize a student, it's only expecting 1. That's why we need to still pass in name and age. We can grab the stuff from above. That's not an issue. We can do that with super, so we don't have to rewrite that, basically what we had there. But we still have to explicitly have that stuff here because that's a part of this class. That's the stuff that it's expecting. So if I run it, perfect. There we go. We have it working again. Okay. Does super make sense with everyone? All right, cool. Okay, so with that being said, I'm going to give you guys a second, and I want everybody here to basically update your person superclass and student and teacher subclasses. Really, I want you to update your student and teacher subclasses to use super for the initialize and for the introduce methods. And I'm going to share with you guys the code. This is pretty much exactly what I want you guys to do, but I do not want you guys to copy and paste my code. I want you guys to write it out yourself. So that way you guys can work through it. And then I can give you another example later to practice it yourself as well. Okay, cool. So you guys are good to share your screen. Actually, wait, before you guys do it, sorry. I'm gonna add to this. So I'll have you guys do this. And then I think I'm gonna do this. Let's go edit this. Sorry about that. Initialize and introduce methods in the subclasses, teacher and student. Never mind. We'll just start with this. I was gonna add on to it, have you guys do a little, I like build onto it more, but we'll just do this. Yeah. So just use super for the initialize and introduce methods. All right, cool. Sorry about that. All right, you guys are good to share your screen now and try it out. So I just added another exercise after. We're finish working on this first and get this working. And then after you guys are done, there's kind of like a bonus exercise. And basically, I want you guys to modify your student class to also have a school attribute, and then modify your teacher class to also have a years of experience attribute. So feel free, or not feel free, but please focus on this one first. Once you have that one complete, then work on the next exercise. And I'll give you guys time to complete both. I'm gonna give you guys a couple minutes to work on this, and then we'll take a 10-minute break. All right, let's go and take a 10-minute break. We'll come back at 8:16. And when we come back, we're actually gonna have a demo from Matt for his homework, actually. I forgot. Thank you, Matt. All right, cool. See you guys in 10. All right, welcome back, everybody. Okay. Okay, so there's one more idea that I want to go through with you guys. It's going to not really be new. It's going to kind of be building upon this a little bit, but I don't know. We'll go through it real quick. And then from there, after that, I'm going to give you guys an exercise to do to maybe basically practice everything it is that we've been doing here. You guys are good to stop sharing your screen for now, and let's go ahead and go through this together. All right, cool. Let me go ahead and share my screen. Yeah. Okay. So, yeah, actually, that's what we're gonna do. I guess before we continue, is everyone feeling okay with everything we're doing so far? Solid. Okay. So the next idea that we're going to go through with regards to OOP and kind of specifically today, kind of building upon this idea of inheritance or this concept of inheritance, is this thing called, excuse me, polymorphism. Polymorphism. So the idea with polymorphism, and we've been doing polymorphism already. When we do this inheritance stuff, when we're doing inheritance and we're using methods from that are from like a parent class, we're already doing polymorphism. So polymorphism basically it's this idea where we allow objects of different classes to be treated as objects of a common superclass. So for example, in the examples we've been doing, we have this student and teacher, and both of these student and teachers have functionality or and can kind of be treated as a person as well, in the sense that we also have this introduce and stuff like that. So that's kind of the idea with polymorphism. Simply is that is we're allowing a what's it called, a subclass to kind of be treated as objects of a common superclass. So student and teacher are both inheriting from person. So both of them are kind of technically in this concept of polymorphism, they're both technically also a part of this person class. Obviously, and their own teacher and person classes as well. That's the basic idea of polymorphism. You guys might hear polymorphism other places. That's why I wanted to make sure at least we touch on the idea of what it is. We don't need to go into any more examples than that. That's what it is. And then the last thing that I wanted to touch on before I give you guys another exercise is the idea of instead of us using super, it's the idea of doing something called method overriding, which is exactly what it sounds like. Method overriding. It's basically instead of us using the method that we would have inherited, we're overriding it to do something else based on whatever class it is. So for example, we're going to do this really simple example. For example, I have class shape. And all it's going to have in here is it's going to have one method called draw. And then all this method is going to do is it's going to return drawing a shape. That's all this method does. So if I was to create a shape, so I'm going to go shape equals shape.new. And if I go shape.draw, shape.draw, sorry, because we're returning, it should just say drawing a shape. Simple as that. Perfect. It says drawing a shape, exactly what we expect. Now I'm going to create two other classes. So I'm going to create a shape. I'm going to create, or maybe I'll do three other classes. I'm going to go class circle, and this inherits from shape end. And then now in here, I'm going to create a method called draw again end. And instead of using super or anything like that and using this same, or just using this same method here because we inherit there, I'm going to return drawing a circle. And so now if I create a circle equals circle.new, I technically don't even need that. And if I go p circle.draw, now we're doing method overriding. The idea here is that even though circle inherits from shape, we're not using this draw method from shape. We're creating our own draw method. We're effectively overriding what draw does. And what that means, and the reason why I'm saying that is because if I commented that out and then ran this again, Now it says drawing a shape because circle inherits from shape. That's the idea with method overriding, is instead of us using the inherited method that we could have used, we're creating one specific for this class, for whatever reason. In most cases, it's going to be because this class does something else. This class circle, we're specific to drawing a circle. We're not going to be just drawing any generic shape. We're drawing specifically a circle. And so that's really the idea with method overriding. And so the other thing I had in my notes, just to show you guys, I'm going to create one for circle. I mean, one for square as well. So I'm going to go class square. It inherits from shape. Make sure I put my end. I'm going to create draw again, and I'm going to do another method overriding. Return drawing a square. And so if I do the same thing, let me go ahead and I'm going to move that up there like that. And so instead of circle, it's going to be square. Actually, I can't do that because that one's different. Different case. Let's go square, square, square. And this is just going to do exactly like what we said. We expect drawing a square. Perfect. Okay. And so the final thing that I'm going to show you guys is that another thing we can do here is I could and this isn't anything kind of building upon this stuff. It's just showing you guys another thing we could do that I had in my notes. So for example, if I did shapes equals circle.new, square.new, and shape.new, now I can loop through those shapes and print out what the draw method basically. So I can go like shapes.each do. I'm going to go shape end, and then I'm going to go p shape.draw. So now based on what shape is, draw is going to change. So let me just do this. Let me clean this up. Cool. Let me go and do Command K, run it again. Perfect. So we see the first time through, it's drawing a circle. Second time through, it's drawing a square. Last time through, it's drawing a shape. And that's because depending on which class we're dealing with, it's going to determine what draw does. And this is the idea with polymorphism and with method overriding, is that we're able to kind of have multiple different classes. And even though we have the exact same method in each class, they're all doing different things. And even though also they inherit from the same class, they're all doing different things technically. That's the idea. Does this make sense with everybody? All right, cool. And yeah, also I just wanted to show you this too. We can like make an array of our objects and then we can iterate over it, like loop through it and print them out, or whatever. We can do something like that too. Cool. So I'm going to share this with you guys. All right. So the next thing that we're going to do for the rest of this class actually is I'm going to give you guys an exercise. Where is the exercise at? Actually, I'm sorry, guys. Give me 1 second. My parents are dropping Stassi. They took her to dinner. I will be right back. I just need to grab her. They're just outside. Alrighty, sorry about that. I am back. Okay, so let me go ahead and grab this example. I mean, this exercise. Okay, exercise slash homework. Okay, so I said exercise slash homework because we're gonna start it now. But whatever you guys don't finish, I'm just gonna make it homework. There shouldn't be much to do, but so I just wanted to like you guys finish it later if you didn't already. So the task is you're gonna plan a program. It's not just plan, you're gonna create it as well. Plan and then create. Okay, so you're going to plan and then create a program that utilizes inheritance and polymorphism to model a real world scenario. So you're going to choose a scenario. You can choose one of the scenarios I give you guys, or you guys can make up one yourself. Completely up to you. So choose a scenario such as a library system, zoo management, school administration, etc. And here's some like examples of what it looked like. The superclass or the parent class would be the library item. Subclasses for book, magazine, DVD. Common methods for checkout, return item. Theoretically, all these methods do, it says it was checked out or whatever. The book was checked out, the magazine was checked out, the DVD was checked out, whatever. Polymorphism, different methods, different checkout behaviors for each item type. So basically, based on what type of class it is, what checkout does is going to change slightly. And same thing for zoo, for example. We'll have an animal and we'll have like mammal, bird, reptile. Common methods for feed and make sound. Different make sound implementations, whatever it is. Or you can choose school administration or whatever scenario it is you want. Completely up to you. And so I want you first to identify the classes that you need along with their attributes and methods. And so what I mean by this is before you start writing the code for all of it, I want you to plan for what it is that you're going to be building. I don't want anyone to just like, okay, cool, I'm going to build this out. I'm going to figure it out as I go along. I want us to think through what we want to do first, and then we can start building it out. So figure out what classes you need along with their attributes and methods, determine the superclasses and subclass, or determine the superclass and subclasses, and then decide how polymorphism and method overriding will be used. And then finally, after that, then you'll actually start implementing it, which might as well just add that here too. Cool. And then after you kind of figure out what it is you want to do, you can begin implementing your program. Start coding, implement the attributes, inheritance, apply whatever, create the instances and demonstrate the interactions, whatever. Does this make sense with everybody? Yeah? Okay. So for the remainder of class, this is what we'll be working on. I basically want you guys to practice, and you guys can use your person, student, and teacher one as a reference because pretty much you're just going to be doing this, but for different like superclass and subclasses. But yeah, so just practice with it. I want you guys to practice it, get used to dealing with different classes and inheritance and super and all that kind of stuff. Cool. So again, first thing I want you to do is just plan out what you want to do. And then after you plan that out, then you can start what's it called, actually coding it out. Cool. If you guys have any questions, reach out to Lana and or I. Yeah, you guys are good to start sharing your screen and trying it out. The other thing is I was gonna have us do some deliberate practice, but because there's only like 30, 40-ish minutes left, maybe we'll save that for another day. Just so that way we're not taking up too much of you guys' time. I want you guys to work on this. That's more important to me right now. So yeah, just right now is you guys' time to work on this. Yeah, you guys get to share a screen and do that now or work on that. And then I'll be right back. I'm just gonna set up Stassi real quick. She needs a shower and stuff. Alrighty, I'm back. Sorry about that. Yeah, you guys are good to continue.
Elian, can I ask a question?
Yes, of course.
So I'm just kind of looking at the requirements or the instructions
For sure.
on my line 105 and 106.
Yes.
I'm- That's kind of how I'm thinking about it. Am I like on the right track?
Superclass name.
I'm thinking this will go in the super class,
Okay.
in the subclass, and this is the method. Is that?
So yeah, I think so. So basically, so you're gonna do library item.
Mm-hmm.
Got you. So library item is gonna be the superclass. Sorry, let me delete that.
Yes.
And then from there, library item is gonna have a name. It'll have a name of
Yes.
what the item is. And then from there, type is only gonna be for the subclasses. Is that right? Is that what you're saying?
Yes.
Got you. And
I'm
then
I'm
what about,
thinking, I'm thinking maybe even this might instead is title is
yeah, that works too.
okay.
Either completely up to you on what name it is that you want to use, or what variable name it is, or what attribute name you want to use. And then what about
Okay.
the status? And is the status going to be a subclass, or is the status is going to be the method that every one of them have? Is that correct?
Yes. I guess that's the part where I'm kind of confused on what to do. So I got the super class, I got a subclass. I can probably add to it the more I understand it,
Yeah.
but then the methods, I'm understanding the method as if it's checked out or it's returned. Is that, am I
In
thinking about that correctly or?
I think so. In my head, the way that checkout and return would work is every one of so the by common methods, every class is going to have it. So book, magazine, DVD, and library item. They will all have checkout and return. But
Yeah,
depending on what class it is we're dealing with, checkout and return are going to do something else. So for example, it could be as simple as if, like for example, that draw one, that the different shapes. So let's say if it's a book, if we do whatever book dot checkout, it's gonna say checked out the book. If it's a magazine, it's gonna say checked out the magazine. If
oh,
it's a
okay, I
DVD,
see.
checked out the DVD. You know, it could be as simple as that. You could obviously add more complex logic to it if you wanted to, but it could just be as simple as, okay, this one is checked out versus this one. And the idea is that we have the same exact method, but then depending on what class it is, it's going to determine what that method does.
Got it, got it. That that clears it up. I was like, how do I, yeah, how do
Yeah.
I do? I was thinking like the date that it was checked out or the
No, no, no.
date that it was checked
I
in,
definitely,
and
yeah, I get where you're going with that, but even so, way simpler. We don't even need that. We're not like it can
okay,
literally just be as simple as that. Yeah.
okay, I understand. Okay, cool.
So,
Thanks, man.
yeah, of course. Any questions, feel free. Sorry, Junior, that was an accident. Uh, where's my thing? But actually I do want you to look at 136. I want you to look at that line. That's where your issue is. It doesn't say it in the code, but that's what the error is. So that did actually, you did need to do that, and I actually wasn't even paying attention to that. And so we can see this error is a little bit different. So the first one was given to expected 0. This one's now given to expected 1. So so this one's it's not super straightforward, but just look at the spelling. It's a spelling issue. So technically, you don't have a method called initialize, and that's why it's like, hey, like you're trying to initialize something, but like what like that doesn't exist. That's what it is. I got you. All right. Okay, so there's a few things that I just wanted to quickly touch on. You guys can continue working. Lana and Ron are still working on some stuff, so I don't want to just wrap up just yet, and I'll give you guys a little more time. But it's like 5 or so minutes. But a few things that I wanted to share for my recommendations for you guys is for one, I recommend to run your code as much as possible. By run your code, test it out. You did some logic, test it out. And the reason I'm saying that is because, and I'm not saying this in a negative way, but there's a but I've seen there's a couple people where I'm seeing you guys do a lot of stuff, but I haven't seen you guys run your code one time. Like your terminal's still in the exact same spot as when I was looking at you the first time. You guys are just writing a lot of code, which is great. However, you don't even know if the code works. What if you have a bunch of bugs that you just added, and then you're adding more code, and so then you're gonna have to go back and debug all that stuff to get it all working. And so that's where, like, for example, you guys saw when I was doing multiple classes, creating multiple classes, the first thing I did was I created the overall super class. And then I tested it out. I actually created, for example, the person. Before I created a teacher and student, I created a person. After that, once I knew that was working, then I'm gonna work on the student. Get that working, then I'm gonna work on the teacher. And then I can test it all together again. And the reason I'm saying that is just because if you don't run your code, you don't even know if it's working. Like just genuinely. And so like down the line, that's going to hurt you because it's just you're going to have to debug a bunch of things if the code that you wrote has a bunch of issues. So I really recommend that. The other thing I'd recommend is just indentation. It's not the hugest thing in the world. I'd say like it's not going to break your code, but to me, for readability's sake, like how do you know where something starts and where something ends and stuff like that? So I'd say focus also on indentation. So those are the kind of the two pieces of feedback that I have for everybody here. Not for anyone in particular, but for everyone here just in general. As you guys are working through these things, it's like work on little things at a time. It's kind of like break things up into bite-sized chunks. I don't want anyone to be doing a million things all at once. And then from there also pay attention to your indentation and do your best to kind of watch that. So that way it's really readable and it's easy to see, okay, this is where it starts, this is where it ends, etc. Cool. You guys are good to continue working. We're gonna work for a little bit longer, not too much longer. I don't want to keep you guys too late, but I did just want to say that real quick as you guys are working. Yeah. So I think the main one though is I recommend really just running your code. Test it out as much as possible, as much as you feel that you need. All right, sorry about that, everybody. Okay, so you guys are good to stop sharing your screen and we can go ahead and start wrapping up. I know it's already 9:21. Okay. Um, does everyone feel okay with what they're doing and all that? Everyone feels okay with today? So and so? You have any questions? You want to go through any specific things, Junior, or is something just kind of repetition? It's repetition? I got you. Cool. So, I mean, if you guys have any specific questions or want to go through any concepts, feel free, let Lana and or I know. Um, okay, sorry. What's it called? But yeah, so this is just continuation of OOP. We just did some inheritance, we did some polymorphism, method overriding. It's nothing crazy. It's just kind of layering on different things with regards to creating objects and we're just adding more functionality. That's really what we're doing. If you guys have any questions again, yeah, sorry. I know I just said it, but just feel free. Let us know. Other than that, I don't think I have anything else. Matt, I'm sorry. I know I said I was gonna have you do it, and then I completely forgot, and now it's already 9:20. So I'll have you show yours tomorrow, as long as I remember. But cool. I'll go ahead and let you guys go. Everyone will present their homework tomorrow. And yeah, so thank you guys for being here. Have a great night, and I will see you guys tomorrow night.
Thanks, guys.
Night, everybody.
Night.